All right, so exercise 3i, discriminants, x squared plus 6x minus 4. If we were to sketch this graph, okay, if we were to sketch this graph, you would know that a equals 1, b equals 6, c equals -4 based on last session, yeah? You know how to use quadratic formula. If you were to use the quadratic formula, you get your answer as this following. Okay, forget about all that. I'm just showing you, if you were to find them and you were to sketch them, this is what you'd get. Now, when we're doing exercise 3i, we're now looking at, when you get an answer, you get two x-axis intercepts when you solve for the x-intercepts using the quadratic formula. Yeah, you get an answer, you get plus the answer, minus the answer. This is what it comes out to. So it means this quadratic equation will cross the x-axis at 0.6 and -6.6. Okay, so if I roughly sketch this graph, this is what it would roughly look like. It'll say, you'll cross through -6.6 and it will look something like that. Okay? With one intercept at -4. You got that graph. Now what we're interested in is b squared minus 4ac. We call that the discriminant. The reason why we're interested in that is because the square root dictates how many x-axis intercepts you will get. So here we go. This is what we say, and I don't want you to memorize this, but you can write it down. So I want you to write it down. We say if b squared minus 4ac is bigger than 0, and this b squared minus 4ac is equal to 0, and you've got a third scenario when b squared minus 4ac is less than 0. I know it looks weird, but all it's saying is whatever you're square rooting, if that number is positive, or if it's 0, or if it's negative. That's all it's trying to say. Now, you think about it. If I had a positive number, if I square rooted a positive number, if I square rooted 4, what's square root of 4?
2.
2. You get a plus and a minus 2, so you get plus minus 2. And what that means is, at the end of it, you'll get plus minus 2. And what happens is you get two answers. You get add that number and minus that number. That's why you get two solutions. You get two x-axis intercepts. What happens when you square root it and it gets 0? Well, this is what happens. When you get square root and you get b squared minus 4ac, if this is equal to 0, you get root of 0. But then why is that important? Because when you have plus or minus square root of 0, you get plus minus 0, which is really just itself. That's why they say, when you have it equal to 0, b squared minus 4ac, and this result is a 0, then you end up with just minus b over 2a. It doesn't matter if you're adding or minus 0. You only get one answer. Whereas this one, you get two answers. You get -3 plus root 30, and you get -3 minus root 30. That's why you get two answers. But if I told you it's plus minus 0, you only get one answer, -3. True? Whereas if b squared minus 4ac ends up being a negative number, then you can't square root a negative number. So if you can't square root a negative number, so think about it, if I square rooted this, if I said square root of a negative number, this doesn't work. If it doesn't work, that means at the end here, you've got -3 plus minus nothing. You don't know what to add or subtract, so of course you don't have an answer. So what does that mean? It just means you have no x-intercepts. So what I'm trying to say is, here, if this condition comes true, we have no x-intercepts, we have one x-intercept, or you have two x-intercepts. And it makes sense in a quadratic graph. If I were to sketch it, see, when you draw a quadratic graph, this is what you get. You can get one x-intercept, or you can get two axis intercepts, or you can get no x-intercept. Now, the only way to tell that, one of the short ways, is we go, oh, well, all you have to do is just look at this. Because this formula tells you how to find the x-intercept. But in the formula, if this screws up, or if anything happens here, it dictates whether you get an answer or not. So if b squared minus 4ac was 0, then you only get one answer. Minus b plus minus 0. It's the same thing. Add a 0 or minus 0 is still the same answer. Whereas if you had a positive answer here, square root of that will give you plus that answer, minus that answer. Whereas if it's negative, well, of course you can't solve it, so that means there's no x-intercepts. Does that make sense? I'll do an example so you can see what I mean, but I just want you to sort of picture that. The aim is to analyze that problem. I'll show you what I mean here. Let's go with, I want to do this right now. Okay, so let's have a look. I'll give you an example where b squared minus 4ac becomes 0, yeah? So let's go with this one. Let's say I give you x squared. Let's go with plus 2x and What's that? Plus 1? Would that work? Yes. Okay, this one will work. Let's have a go. So if I asked you to find the quadratic formula, if I asked you to find x squared, the x-intercepts, you would say x is equal to negative b. So my a and b, so negative b would be negative 2 plus minus square root of b squared, which is 4, minus 4 times a times c divided by 2 times a. Yeah, so I'm just looking at this. A is 1, b is 2, c is 1. I'm just following the formula over here. Okay? If you simplify this, negative 2 plus minus, what you can see is 4 minus 4 ends up being 0. Yep. Okay, so what you can see here, this is key. See, if I ask you, well, you just worked it out. This is b squared minus 4ac. If that equals 0, what I just explained is you should only have one intercept. Because logically, if this is 0, now you think about it. Negative 2 plus 0 or negative 2 minus 0 is still negative 2. So my two scenarios, if I show you right now, the two scenarios that you get, you can either get negative 2 plus 0 divided by 2, or you got negative 2 minus 0 divided by 2, and that ends up being negative 1 and negative 1. That's why you only get one x-intercept. Now let's test that. I'm going to sketch it on the graph so you can see. Where's the GeoGebra? Here we go. Okay, so we said it was 1x squared. Watch, I'll show you. 1x squared. I'm just going to make this larger so you can see. Large, bold. Watch this. So if I change b to 2 and I said 1, can you see the graph only has one x-intercept? Yeah? Now we said before, well, we said that if b squared minus 4ac is larger than 0, it should have two x-intercepts. True? Now the only way to have larger than 0, this is 4 minus 4, well, I just need to change b. Now if I change b to make it larger than 4, because this is b squared, so remember the formula is b squared, I can try 3. If I try 3, I'm going to have 3 squared, which is 9. 9 minus 4 is 5. That means I'm going to get two answers. True? Yes, I'm going to change it to a 3. So watch. If I change this to a 3, if I just change this equation, I said, let's make b 3 now. So what you get, watch, I'll change it to 3, and what you should expect is two x-axis intercepts. I might not know where, but I know I should have two x-axis intercepts. See what I'm doing there? So all you're analyzing right now is, okay, well, what if I want no axis intercepts? What if I want that not to have any x-axis intercepts? Then I'm going to look at this and I'm going to, all right, let's just make sure b squared minus 4ac is negative. Because if it's negative, I can't square root it. If I can't square root it, I can't get an answer. If I can't get an answer, I don't have an x-axis intercept. Does that make sense? Yeah. So the only way to not square it is if the answer is negative. You can't square it a negative number. So now would this become negative is if minus 4, if the only way to get a negative is this number is less than 4. So let's try 1. See, if I try 1, 1 squared is going to give you 1. 1 minus 4 is going to be a negative answer. True? So let's try 1. If I try 1, you should expect it has no x-axis intercept. So watch. I'll try 1, and let's have a look. So b becomes 1, and look at that. At 1, see if it makes sense. It has no x-axis intercepts. You see, you didn't have to sketch it to see it. You can only just analyze the formula, and the formula was this. It was just b squared minus 4ac. If that was negative, because that just means less than 0, if it's negative, we have no x-axis intercepts. If it's 0, it makes sense. We're only going to get one axis intercept. If it's greater, it's a positive number, of course, because when you square root it, you're going to get two numbers. You're going to add it and then subtract it, get two axis intercepts. That's why it makes sense. Anyone confused on what I just said there? Yeah? So what we're going to do in this whole exercise is you're going to be trained to find out what values can I have to make sure I get one or two axis intercepts, one axis intercept, or 2, or 0. Okay, that's the goal. Instead of trial and error like I did just now, I just said, let's try 2, let's try 3, let's try 1. We don't want to do that. We don't want to keep trial and error. There has to be a method to solve for this. There has to be a logical way of doing it rather than plugging in numbers and going, let's see if it has an x-axis intercept. That's a waste of time. There has to be a technique. That's why 3i requires everything that you know. You have to be able to sketch it, you have to be able to analyze it, and then answer the question. That's why 3i is really hard. Okay, so let's have a look. now that you got the idea, this is what I want you to do. We're going to do this together, yeah? This is my new equation. I've changed m because I don't know what the last value is. So whatever m is, that's going to change whether I'm going to get 2 axis intercepts, or 1 axis intercept, or no axis intercepts. So how do you work out whether you can have any axis intercepts? B squared minus 4ac. This will tell you whether you're going to have an axis intercept or not. Let's do this. B squared minus 4ac. This is my B. This is my A. That's my C. So I've got B squared, which is 6 squared, minus 4 times the 1 times C. Now I get this equation. Okay? When you get this equation, what a lot of students don't realize is, what does it mean? Okay, so I'm going to show you here. Discriminant by 36. So I'm going to write it here. Discriminant equals to 36 minus 4m. What does that mean? Now, if I told you that I wanted 1 axis intercept, what do you need again? What, in order to have 1 axis intercept, going back to what you just saw now, b squared minus 4ac has to be what to have only 1 axis intercept? Negative. Has to be 0. If it's negative, square root of negative is undefined. That means no axis intercepts. If it's positive, square root of that will give you 2 axis intercepts. True? So the only way to get 1 axis intercept is if this equals 0. Now let's test that. If I wanted to have only 1 axis intercept, let's try it. If I let discriminant equals 0, so that means 0 equals 36 minus 4m. Let's solve for this. Minus 36 on both sides, minus 36, minus 4m. M has to be 9. So apparently, if m was 9, I should have 1 axis intercept. Let's test that. Let's try that. So I've got 6x. 6x, change it to 6. There we go, I got 6. Now we said apparently if m was 9, so instead of 1 here, if that was 9, I should have 1 axis intercept. So let's check that. Watch. When I change it to 9, without guessing, I do get 1 axis intercept. See, that's the skill. The skill that you're learning is analyzing b squared minus 4ac. What do you want? And you want, if you want only 1 axis intercept, that's what I just did. I just said discriminant has to be 0. If it was 0, I can figure out what that is. Does that make sense? Let's try another one. I'll do it on the board. Let's do this one. Let's say, I give you this one now. I'm going to change it. So let's say I give you y equals to, let's go 2x squared plus mx minus 4. Right? Now we don't know what m is. M can be anything, but let's say I want this graph to only have 1 x-axis intercept. Okay? Now again, how do we have 1 axis intercept again? What do you have to have?
0.
Good, discriminant has to be 0. Discriminant needs to be 0 for this to occur. Now what's the discriminant formula again? How do we find that? Good, this was b squared minus 4 times a times c. We need that to equal to 0. Because that will give you 1 axis intercept. Yeah? So we're just looking at the formula again. So let's try this. What's my B, what's my A, what's my C? We're looking at this. This is my A. This is my B. That's my C. Let's put it in together. B becomes m squared minus 4 times A, which is 2, times C, negative 4, equals 0. I'm just doing A squared minus 4AC, yeah? My A, B, C. True? So I times them all together, this becomes m squared, negative 4 times 2 times negative 4, which is 32. 4 times 4 is 16, times 2, that's 32. Yeah? Yes, absolutely. Okay, so this means the discriminant.
Does it have that little thing on the top, or is that just you wrote it?
Which one? Okay. Now, here's the question. If I were to solve this now, m squared plus 32 equals 0, I want to solve for this, you would say minus 32 on both sides, true? This is what you're going to get. You get m squared equals minus 32, but here's the problem.
So 0.
You can't square root negative 32. So what does that mean?
Undefined.
No. So what does that mean? So what? Sorry, no. When we were solving for the x-axis intercept here, we said if the discriminant was equal to a negative, you can't have. But what does it mean when you can't have m? So I wanted to have one x-axis intercept. This tells me I can't have m.
There's no gradient.
Say it again. There's no gradient. Not gradient. Something else.
Wait, I thought M was in.
No curve. No, there is a curve.
How do you write this?
See, m is this number. And what my goal was, what did I want to get? So remember, I said I wanted one x-axis intercept. If I can't solve for m, that means I can't get only one axis intercept. Okay, so let's test this. Look, I can change m as much as I want. So watch this.
This 4 is negative.
See, look, I can have 2. C is -4. Wait, where's -4? -4 is here. What? That's -4, right? Now what I want you to see, I can change m as much as I want. You watch, I'm going to move that scale up and down, and you watch, you'll never get one axis intercept. It just wouldn't happen. Because that's what I can do. I wanted only one x-axis intercept, but I couldn't solve that. I couldn't find a solution to that. I couldn't make it possible. Because I couldn't make it possible means I can't make this goal possible. So the goal that I wanted was to have one axis intercept. Now watch, I've got 6 there. Now watch, I'm going to change m. I'm going to change the value for m. So watch this. Doesn't matter how I change it. It's always going to be 2 axis intercepts. It doesn't matter.
So M has no.
Because I put m here. If I had changed it, if I switched it around, watch this. If I switch this around. If I switch this around, so if I said, let's make this 4, and I call this m, now this is different. See, if I change that, this means this whole thing changes. So let's say this is my goal. This is still my goal. I still want, the goal is, I want to solve to have only one axis intercept. Now how do you do that? This has to work. This has to work for this goal to be achieved.
I know, but what I'm saying is,
So we'll say that there is no, you can never get one x-axis. By m, you can't. It just won't work. Like, there's no values of m to have one x-axis. One x-axis. Yeah. Yes, and that's what I can do. That's the harder ones. So the ones where you want to find, you want to have 2 x-axis intercepts, or you want to have no x-axis intercepts. It's harder because they'll change this to either greater than or less than. And that's why you needed 3G to be able to do this question. And I'm just starting off with equals so you guys understand what I'm saying. Yeah, so I'm just starting off with equals. So here, in this particular problem, I changed m. I said m now is 2x squared plus 4x plus m. And my goal is, what should m be so that I can get this thing? This is what I want. I want this graph to only have one x-axis intercept. What I don't want to do is keep trial and error until I do, right? So what I'm going to do is I'm going to try to figure this out. So how do you figure it out? Discriminant needs to be 0. That's what we know. If this is true, you will get one x-axis intercept. So let's try to make it true. Let's try to solve it. We've got b squared, which is still now 4. So b squared is 4. Minus 4 times a, so 4 times a is 2 times m. I need the discriminant to equal 0. Let's work this out. This now becomes 16 minus 8m equals 0.
Plus 16, but minus 16.
Minus 16 on both sides, so negative 8m equals to negative 16. M equals 2. Not negative 2, negative make it positive. So what this means is, yes, there's an answer for m. So that means if m was 2, so if m equals 2, I will achieve this goal. See what I mean? So it's the goal. The goal is I wanted one x-axis intercept. This had to be true. Because look, he said solve for it to make it true. 2 will make it true. Since 2 makes this true, that means I will get one x-axis intercept. See what I'm doing? So let's test that. So if I change this equation now, if I wrote 2x squared plus 4x plus 2, let's see if I only have one x-axis intercept. And you watch. So instead of trial and error, you don't have to trial and error anymore. I'm going to go back. 4. And then now, see, we said it had to be 2. So watch. I'm going to change it to 2. And what? There we go. So there was no trial and error. We knew that from the very start because it's all mathematical. It was logical that we can figure out when you will have one x-axis intercept. You might not know where it is, but you know for sure this graph is going to have it. And your goal is only based on this. Okay? Now let's try another one now. Let's try to make it a bit harder. This is for one x-axis intercept. But what if I want two x-intercepts. So if I change the goal, so I said 1 here, what if I said I want 2 x-axis intercepts? Okay, so this is going to have different answers now. This is not just going to be one answer. This is where you needed 3G. So let's have a look at this. If I change this to greater than 0, how does it change things? This is why you had to do 3G. So here we go up to this step. Everything's the same except for this part. It's greater than 0. B squared minus 4AC is still 4 times A, which is 2. Oh, sorry, times C, which is M. And that is still, what's that again? B squared, so 16. 16 minus that. We want that to be greater than 0. Yeah, so I just did B squared minus 4AC is greater than 0. Now we get up to this step, you get up to this point here, you got 16 minus 8m greater than 0. Up to this step, this is where a lot of students make a mistake. If that was a quadratic, most students would try to solve it like as if that was an equal sign. So that's where you get it wrong. At this step, you have to visualize what this looks like. So you're going to have to sketch this now. So this is your discriminant. This is your m values. You're going to treat this as if it's y equals to 16 minus 8m. You have to pretend it's that graph. Okay, and if I were to sketch this, what kind of graph do I have? What is this? Quadratic, linear, cubic, what is it? Linear. Good, that's your y equals mx plus c. See, this is your, sorry. See, that's your gradient y-intercept. If you were to sketch this, this is 16, that's your y-intercept. If you were to work out your x-intercept, you would say let this equal to 0, that's 16 minus 8x, you solve for it, that's 16. That's what we were doing just now, yeah? And we got x equals to 2. What that means is on your m values, it's a negative gradient. This is what it looks like. Now, what does this mean? So why would you have to do 3G? And I said if you didn't do 3G, you'll find everything else afterwards hard. Remember how I told you greater than 0, less than 0? This is your graph. Now, what do you want? Greater than 0. So where is it greater than 0? That's where it's greater than 0. How do you get those values? Anything less than 2. See, any values that I choose less than 2 will have a y-coordinate. So if I chose x equals -1, you can see there's a y-coordinate that is positive. But that's your discriminant axis, so it tells me I have a positive, anything less than 2. So apparently, if I chose anything less than 2 for m, I should have 2 axis intercepts. Now let's test that. If it's not 2, what's less than 2? Pick a number that's less than 2. 4. No, not 4. -4, right? Watch. If I change it to -4 now, if I change it to -4, watch. I should have 2 axis intercepts. -4. See that? 2 axis intercepts. If I change it to -3, -1, 1, -0.25. But the time, as soon as I am about 2, see, as soon as I hit 2, it's 1. But as soon as I pass 2, it's greater than. See what I mean? And it makes sense because you can look at this graph and say, if I chose anything bigger than 2, the discriminant, see if I chose 3, the discriminant, that discriminant value is a negative value. Negative discriminant means this is less than 0. If that's less than 0, like we said before, you can't square root anything less than 0. That's why you have x-axis intercepts. That's why it's hard. See what I'm trying to say?
-16 divided by
It's still the same. Yeah. And that would only work because it's linear. So if I change that, if I give you, yeah, I think if I change this to m squared, and then I kept that m, you will now get m squared. And you can't do that. And that's why you have to use.
So both of them negative b.
Yeah. Maybe no, that works. So you can do m plus 1 if you want to, or whatever it is. But
So it'd be m sorry.
And that's why it gets like
Does that happen often?
oh yeah, absolutely. All the time. That's why in 3G, remember when you sketch it, you get quadratics. And they kept saying, when is it greater than and when is it less than? Because it allows you to do this question. Because if you get a quadratic equation here, if you get m squared minus 8, and you want it to be greater than 0, this graph will actually look like this. This is m squared minus 8. M squared minus 8 now, going down by 8. This is m, discriminant. So you can see, when is it greater than 0, it's from this point onwards, and from this point onwards. That's why you can't just solve for it. You can't just say, oh, it's m squared greater than 0, than 8, and then m is greater than plus minus root 8. You can't do that. That's not going to be true. Okay, that's why you have to know how to do 3D. Alright, one last example, and I'm going to get you to think about just do discriminants. We're not going to have to solve this. This is a really hard type of question, yeah? Let's try another one.
So we can try and find a set.
Let's try... Alright, let's try this one. Here we go. Let's try this. So I want you to copy this down. Right, year 11, quiet down. Boys. Thank you. Here we go, last example. And then you go to your long weekend, have a think about this. I'll make more videos and I'll do every question of exercise 3i because I know it's the hardest one. And it's the only one that you really learn as a new concept for year 11. Okay, you've never learned this before. This is the first time you're learning this technique. So I'm doing all examples on what I've given you. So watch it, learn how to do this. Yeah, they're the most important skill. So here we go. Same thing. We've got this equation. Here's the goals. Same goals. They say, I want for what values of n will the equation have a unique solution, meaning one x intercept. That's what it means. Unique means one. Yeah? No solution means no x intercepts. Okay, so let's say we want one. Now, from what we understand before, the only way to get one x intercept, what do you have to have? Something equals, yeah, good. Discriminant equals 0. That's what we need. This is what we need. We need discriminant b squared minus 4ac. It must be 0. That needs to equal to 0 to have only one x-axis intercept. So that's what I'm going to do here. I'm going to find out discriminant b squared minus 4ac. This is my equation. What's my a? This is my a. That's a. What's my b? This is my b. The whole thing here is my b. The value in front of x. What's my c? Negative m. So that's my c. So I'll put it all. What's on the x? You don't worry about the x's because a, b, c is the values in front of x. Yeah. Okay. So you got y equals ax squared plus bx plus c. This is your general equation. A is the number in front of x squared, b is the number in front of x, and c is the number of x. And you have to solve that. So now let's do this. B squared, which is n minus 4 squared. So that's what I got here. N minus 4 squared. Minus 4 times a is 4. So I got 4 there. Times c is negative m. Yeah. Okay. So now when we expand it, negative 4 times 4 times negative m should be. Wait, did I do a mistake there? No, I didn't. No. Negative 4 times 4 times negative m is positive 16m. But what I did here is I expanded n minus 4 squared. Yeah, remember in your quizzes I asked you to expand, learn how to expand m minus 4 squared. So m minus 4 squared, if we expand that, that gives you m squared, so square the first one, double negative 4, so negative 8m, and then square the last one, plus 16. Yeah, that's how I got that line there. Now let's simplify that. M squared, you've got minus 8m plus 16m. That gives you positive 8m. You still got a plus 16. So this is my equation. But what did I want again? I wanted one x-axis intercept. And what you said to me before, you said as long as discriminant is 0, you will get one x-axis intercept. So if this equals 0, so have a look, if this equals 0, you will get m squared minus, plus 8m plus 16, it has to equal to 0. Sure? Now the nice thing is, this is nice because it's equal to, and we can solve this. This is your quadratic stuff that you've been doing, 3c. I told you to learn 3c to solve this. So let's solve this. How do you work this out? Let's do it. Good. See, if you factorize this now, 8, this is a perfect square if you think about it. It's m plus 4 times m plus 4. M squared, 4m plus 4m, 4 times 4. This now gives you m plus 4 squared. And remember in exercise 3c, in order to solve, you can square root both sides. And that gives you now 0 equals to m plus 4, minus 4 on both sides, m is negative 4. So what does that mean? In this equation, if m is negative 4, you should only have one axis intercept. Now, I'm not all about solving because this is easy when it's equals to. The one that you want to use is when it's greater than or less than. So the best way to do this is before you even start answering questions, you should be sketching the problem. So here we go, we're going to do this one. Instead of doing it by algebra there, I'm going to sketch the problem. So what you just figured out was discriminant by m, you just figured out it's -4. True? The reason why I taught you 3D is if I asked you to sketch this equation, if I asked you to sketch this, m plus 4 squared, remember from exercise 3D, what does this tell me? It's a turning point form. What do I know about this graph? What's the m plus 4 tell me? Moves where? Left by 4. So I know, and is this a smiley face or is it a frown face? Smiley face. So it moves to the left by 4, doesn't move up or down. So if you were to sketch it, what's the y-intercept? How do you find the y-intercept? Which is this value, because we don't have x-axis anymore, we got m values. So therefore, let m equal 0, and you get discriminant equals to 4 squared, which is? So that means it should be 16, but you don't really need to worry about that. Because we're on 3G, we never worry about the y values. Now if you look at this, what does this imply? So if you look at this, this is your discriminant axis. And look at all the y, it doesn't matter which x value you choose, the discriminant is always positive. So what does this mean? This means that you're always going to get 2 axis intercepts. You see what I mean? Because if you have a look, if I chose 3 over here, look at the discriminant. This discriminant is positive. But if it's positive, if the discriminant is bigger than 0, if it's positive, you have 2 axis intercepts. The only time you don't have 2 axis intercepts is right here. Right there, that's when m is -4, m is -4, but the discriminant at this point is 0. So you only get 1 x-intercept at -4, but everywhere else, you're going to have 2 axis intercepts. We can prove that. So watch, I'll show you. I'll make it up right now. I'll show you. Here we go. We're going to change the equation. I'm going to ignore this one. We're going to do the same thing again. Actually, I'll make a new graph. Sorry, I'll make a new graph. Here we go. Let's try this one. So, watch. So the equation that we've got was 4x squared. So watch, I would do f of x equals to 4 times x squared. Whoops. 4 times x squared. And it was plus, oh no. Can someone read it to me? 4 times x squared plus, what was it again? M, anyone write the equation? The original equation. Was it m minus 4 minus m? Okay. M minus 4 times x minus m. Now watch this. If I change m, remember we just said m needs to be bigger than 4, and that's what we just figured out. We said it doesn't matter if it's bigger than -4 or less than -4, you should get 2 axis intercepts. And you watch. If I change it to -4, right at -4, if I can reach it, -4, you get 1 axis intercept. But watch, as soon as I pass it, I get 2 axis intercepts, I get 2 axis, oh, it's -5 there. Let's go to -10, 10, 1, 2, 5. All right, here we go, watch. 2 axis, 2 axis. You can never get no solutions. See what I mean there? You always get 2 axis intercepts. And that's what I'm saying, you don't have to trial and error to figure it out. This is where it comes from. That's why 3i is really hard. Yeah, like I said, if you can't sketch, you can't solve, all those skills there is 3a to 3f. None of this you can do, you can't do those. That's why I was very hounding on you to do 3a to 3e. Yeah? All right, now the bell's just about to go. Can I please have the following students? Or just to show me exercise. I haven't seen exercises books for Sydney, Ian, Finn, Felix. Can I see that before you guys go? I am having a class here for half an hour to help those who are in need. So it's a support class. Students that I want to stay, I already put a note on it. So please read your note and stay, and the rest will go. Thank you.
So, can I read the
I was doing the exercise. I hardly ever catch like this year.
Same thing, show me.
I only ever catch
Time to be trusting in the unit until
that's my
Tuesday.
9% of time train.
Oh.
It's that one.
I forgot to remind you.
Sorry. I was away on the lunch break. Yeah, it's just I spent like 10 minutes thinking about Singapore and I realized you don't make it just much. It's not like the make it for you, it's less than that's why I
still need to see it.
Oh, that's a troll. You're like today's gonna be epic because everyone's gonna be active. So now that's an epic.
Everybody, I guess? Yeah.
I'm sure I'll text you.
Okay. I'll go from A, B, C, D, E. So all exercises, I'm going to do each one of those. Yeah. All right. Here we go. Up on the board.
Some probably only get like 3 right.
No, if you get 3 right, that means you haven't done the whole exercise yet.
Yeah, I'll practice.
Space.
I'm going to give him some questions.
I'll practice the 2 at home over the long weekend. He's already
Somewhere. Have a what?
Yeah, that's fine.
All right, here we go. Again.
My cats don't have a label on them.
I think I had a label. I do. I'll just put the label and stick it on. All right. Cool. Let's grab a seat somewhere up here.
Is there a room up there?
Yep.
Wait, are you teaching here?
I'm teaching those 3. And maybe Sydney, depending on if you've done
I'm just saying this one. Whoa.
I didn't watch your name, I didn't call you. In fact, I wrote a note that says well done. Okay, let's go with, this is for Sydney, so none of you are meant to help him, yeah?
Well, I'll just stand for something. I'll just stand for a while.
Okay, but just don't help him. Yeah? I'm trying to test if he knows his stuff and whether he's done his work. Alright, let's go with...
Answer for that question is, come on, 4x squared minus 6x plus 9. We good. 9 plus 9 plus 9. Reset. Alright, let's go. The answer for that question is yeah, 6 is a bit too hard. Nah, that's not What are you running on? So minus 4. Did you really get 30? Well, yeah, I got 4. Whereas on my engineering exam, I got E. Oh, is this like the cross method? So this so easy. These are hard ones.
Well, if he can't do the easy ones, then that means he hasn't done his homework, true?
So I think cross multiplying.
No, this is just for Sydney. Yeah. Because I've seen your exercise book, so I know what you can do. I'm just here to help you guys. Whatever you're up to, start on the exercise where you're missing.
That one's so much hard.
Yes. What about?
What do you mean, Sydney?
Holy shit, I actually don't know how to do it.
Just expand.
Oh, yeah, speed expanding. See expanding? Off on X.
Yeah, here we go. Go to work, Sydney. Oh, yeah, Sydney.
Oh shit.
What number is it?
Yeah, Sydney.
Yeah, boy.
Hey,
Mom.
It's B, right?
Yeah, what's up?
2x.
Do I want to off that? No,
Yeah, you're not meant to help. If you're gonna let me help you get out of the class. Yeah, I'm trying to assess what he knows. So that's why I told you not to stay.
Sorry. Can I move that over?
I'm just saying, this is all part of your homework. So I'm just gonna test what you know.
Can I have a long
Then you staying?
yeah, right.
Well, you got places things to do. Sure. I don't know why you're in my class when you didn't do it. Yeah? Because from your reaction before, it tells me you haven't even done 3H. So I know you're really behind right now.
So, this Sydney and Tiger are
I'm just gonna go my way. I don't know if this is my way.
Alright, cool. I'll leave it there. Alright guys. Questions? Was I right?
Yes.
Exercise one?
Yeah. I told him through the active thing. He's like, no, it's like,
No, I didn't have time. Tell me, I would have been more understanding there. I was scared, yeah. I was scared that I was assuming something that wasn't true. That's why I wrote, this looks like, I didn't actually say you did.
you were right. Sydney, that's not.
Alright,
what are you doing?
you got up to, it seemed like up to 3 weeks somewhere there.
I need to do plus 12 minus part.
Is that correct?
I can. What's 3D?
Factorizing, so that one.
Oh, yeah, I can do that.
Oh, good. Good. So we can move from 3B.
Yeah.
Back to 3C. So 3C, you should then be able to use 3B to
Yeah,
solve it.
so make it 0.
Yeah.
Yeah.
Okay. Let's just do one in front of me so I know. Let's try this one. Will.
Yeah.
Right. You want to sit down and I can help you? Or?
Yeah. Just need some help with the square.
Oh, this is that's how I'm trying to teach.
Hey, Ian, bro, can I grab my book? You sit on it.
What?
Okay.
I tried to solve it, I was like,
No, that's cool.
Ian, can I have my pen?
sorry.
Nah, you're alright, bro. Thanks for the music.
Read the question.
That's not my fault. How's that my fault? That's not.
Yeah. All of these, all of this
Something big.
Fucking X intercept.
Oh, I need one.
Look, why? I'm doing 3B. Heavy squares. Oh, is that what you mean? Oh, right. Okay, I'm trying to people it. A squared plus double whatever A is 2 times double AB plus A.
I have to write it out.